This is the mini lesson for lesson 2.1. First of all, I marked my text here where it says 1 out of 4 students likes country, 1 out of 3 likes rock, 1 out of 5 likes hip hop, and the rest have no musical preference. So we're going to use that information to interpret the survey results given the total number of students, and we're going to complete the table. So if I'm trying to figure out the number that prefer country, I'm going to go up here. 1 out of 4 likes country. So one person likes country out of 4 people. And so if I have 60 total people, how many like country? And I could see I can scale this up times 15 times 15. So I would get an answer of 15. Now I could continue to use this ratio and continue to scale up for 120, 180, 240. But instead I'm going to look here. 60 times 2 is 120. So 15 times 2 is 30. We can find those relationships within a table. I see that 60 plus 120 is 180. So I could take 15 plus 30 and get 45. I could also see 60 times 3 is 180. 15 times 3 is 45. For 240, I can see 60 times 4, so 15 times 4. I might see 120 times 2, so 30 times 2. However you see it is fine. When we move into number 2, as the total number of students increases by 60, so this goes up by 60 each time, by how much does the number of students who like country increase? So this is going up by 15. You will go back and fill in the rest of the table using the data up here and then finishing this page. When we move to the next page, I'm going to try to put these side by side so we can see that data. I'm going to just continue using country music. So when I look here, if there's 600 total students, well, when there were 60, I had 15. When there's 600, 60 times 10 is 600. 15 times 10 is 150. I see that this doubled is this. So 600 doubled is 1,200. You will have to finish the rest of the table. So we're going to need to get these other numbers to get this first column to be able to get this second column. So I'm going to leave this for you to finish later. Now I'm going to be taking the data given on both those tables and we're going to plot it on here. So first thing I always want to look at when I have a graph is I want to look at these intervals down here. So it goes 2 lines and it's 300. That means each individual line goes up by 150. And going up, it skips a line and goes to 80. So this first line, every single space here represents an additional 40 as we go up. So when I try to plot these, it's going to be a little hard to do these first ones. Total students, 60. So if this is 150, half of that would be 75. So it's just a little under half. And then I have to go up to 15. So half would be 20. So probably right around there would be the dot to represent that point. If I'm going to do this point, 120 students, if this is 150, it's less than that. And go up to 30, it's probably going to be right around here. 180 is going to be a little over 150. And then I go up to 45, it's just going to be a touch over this line. 240, going to be a little closer to the 300. And now I go up to 60. 60 is right between 40 and 80. So maybe around here. And I'm going to continue. So 600 and 150. 600's here. 150 will be less than the 160. So around there. And 1200 and up to 300. This is 240. If we're going up by 40, this would be 280. 300's right in between these two. Looks like right around here. And then I'd be able to continue. Once you have the data right here, we'll continue to plot those points. Now you're going to notice that at this point, all I did is plot the points. I didn't connect the line. We have to make a decision on if we want to do that. So let's go to the next page, and we're going to mark our text here. Data sets can either be discrete, this is going to be one of our vocab words, or continuous. I'm double underlining both. As quantitative data, discrete data are counts of how many, or the data can only have values that are counting numbers. So this means we cannot have decimals, and we cannot have fractions. So there's no decimals, no fractions. Continuous data are measurements and can have values that fall between counting numbers. So this would include fractions and decimals. So now if I go back to looking at this, I'm going to make a decision on if I should be connecting the points or not. So this is on number of students and students who prefer country music. Because I can't have half of a student, that wouldn't make sense. My data is all just representing students. It would not make sense to connect, because if I connected, that would include like the 300.5 student. It would include the 350.2 student. It would include anything along that line. So if I only can have it count for 1, 2, 3, 4, 300, 600, 625, just counting numbers, then I just need to leave the dots. So for this data, it makes sense for me to just leave them, and that would be considered discrete data. It's only the counts of how many. Another thing that we need to talk about are the terms on page 73. So I'm going to look at direct variation. A function represents a direct variation if the ratios between the output values and the input value is a constant. If two quantities vary directly, okay, this is basically the same thing as saying direct variation. The points on the graph form a straight line and the line runs through the origin. Those two things must be met for something to have direct variation or vary directly. So I'm going to add a separate note here that it must be straight line and it must go through the origin. And if you forgot what the origin is, it's the point on the graph with the ordered pair 0, 0. So I can say right here, this point right here is my origin. And then it says you can also describe the quantities of a direct variation relationship as direct proportions. So you will hear these terms all used interchangeably. Direct proportion, direct variation, vary directly. So here's an example of what a graph would look like if it varies directly or is direct proportions. It's a straight line. It runs through the origin. Okay, this concludes lesson 2.1. Now you can go back in the book and continue back with problem 1, finishing the table and working your way all the way through the graphs.